So machine intelligence refers to the ability of a computer or machine to perform tasks that normally require human intelligence, such as learning, reasoning, problem solving, perception, and understanding language. It is a core idea behind artificial intelligence, enabling machines to think and act intelligently. So let's define intelligence. So here we are going to discuss two things. One is human intelligence, another one is a machine intelligence. So the ability of humans to learn from experience, adapt to new situations, understand complex ideas, and use knowledge to manipulate the environment. It is called human intelligence. And the ability of machines, so previously it was ability of humans. Now the ability of machines to perceive their environment, analyze the data, make decisions, and take appropriate actions to achieve goals, often without explicit human instruction. It is called machine intelligence. So in simple way, if we define intelligence, it is the ability to acquire and apply knowledge and skills effectively to solve problems or adapt to new challenges. So machine intelligence is equals to artificially created ability to think, learn, and act intelligently. Please make a note of this. Machine intelligence is equal to artificially created ability to think, learn, and act intelligently. Next one is components of intelligence. So we have 8 components here, starting from learning, reasoning, problem solving, perception, language understanding, knowledge representation, planning, and creativity. What is the meaning of learning? Learning is the process of gaining knowledge or skills from the experience or data. Example, machine learning algorithms learning from past data to predict outcome. Second component is reasoning. It is drawing conclusion, making decisions, or solving problems logically. Example, AI systems deciding best moves in a chess game. Next component is problem solving. So what is the meaning of problem solving is finding solutions to difficult or unfamiliar tasks. Example, navigation system finding the shortest route. Next component is perception. The meaning of perception is understanding the environment through senses. Example, vision, sound, etc. The example for perception is computer vision identifying objects in an image. Next component is language understanding. The meaning of language understanding is interpreting and generating human language. Example is ChatGPT understanding and answering text queries. Next component is knowledge representation. The meaning or function of knowledge representation is storing and organizing information so machines can use it effectively. Example, databases or ontologies representing facts and rules. The next component is planning. The meaning of planning is setting goals and determining steps to achieve them. Example, a delivery robot planning an optimal route. Next component is creativity. Generating new ideas, designs, or solution is the function of creativity. Example is artificial intelligence or AI creating artwork, music, or writing stories. Here you can see the clear differences between human intelligence and machine intelligence. Human intelligence is natural and biological, but when it comes to machine intelligence, it is artificial and computational. So in case of human intelligence, learns from experience. In case of machine intelligence, learns from data. So again, when it comes to human intelligence, uses emotions and logic. So machine intelligence uses logic and algorithms. Human intelligence, flexible and adaptive. Machine intelligence depends on programming and data. Human intelligence example, human thinking. Machine intelligence example, AI models like ChatGPT. In short, intelligence is equal to learning plus reasoning plus perception plus problem solving plus decision making. Machine intelligence tries to simulate all these abilities using algorithms and data. Once again, intelligence is nothing but learning, reasoning, perception, problem solving, and decision making. Machine intelligence tries to simulate all these abilities using algorithms and data. Next, difference between human intelligence and machine intelligence. So, basis of comparison, the first one is nature. So, the nature of human intelligence is biological evolution. In case of machine intelligence, it is artificial, created by humans through programming and algorithms. Next is origin. So human intelligence origin is the product of human brain and experiences. When it comes to machine intelligence, it is the product of computer science and engineering. Learning process, in case of human intelligence, learns from experience, observation, emotions, and environment. In case of machine intelligence, learns from data and algorithms. So creativity. So in case of human intelligence, highly creative, can think imaginatively and produce original ideas. When it comes to machine intelligence, limited creativity, depends on data and predefined logic. Next one, emotions. Influenced by emotions, feelings, and consciousness. Machine intelligence has no emotions or consciousness. So see, decision making. Human intelligence uses logic and emotions, sometimes subjective. Machine intelligence is purely logical and data-driven and objective. Adaptability can adapt quickly to new situations with minimal data. When it comes to machine intelligence, needs retraining or pre-programming to adapt. Speed and accuracy. Human intelligence slower but can make intuitive decisions. Machine intelligence much faster and more accurate in repetitive or data-heavy tasks. Memory. When it comes to the memory, human intelligence is limited and selective memory may forget or distort details. Machine intelligence stores and retrieves large data accurately without forgetting. Error handling. Human intelligence can make mistakes due to fatigue, emotions, or distraction. In case of machine intelligence, low error rate once trained properly. Energy requirement. Human intelligence needs food and rest to function. Machine intelligence needs electricity and computing power. Human intelligence depends independently, can think on its own. Machine intelligence is dependent, needs human programming, data, and maintenance. When it comes to the development, human intelligence evolves naturally over generation, where machine intelligence improves through updates, training, and algorithms. Example for human intelligence, humans, teachers, doctors, artists. When it comes to machine intelligence, ChatGPT, Siri, self-driving cars, robots, etc. Agent and environment. Agent. An agent is any entity that perceives its environment through senses and acts upon that environment through actuators to achieve a goal. So here I can see agent, action, environment, again perception. So sensors, agent is using sensors. So these are the effectors. Okay, these are the effectors. Agent equals to perception plus action. So agent type. So if it is a robot vacuum, sensors or camera, dust sensors, actuators or wheels, suction motors. If it is a self-driving car, cameras, GPS, radar are the sensors. So steering, accelerator, brakes are the actuators. Chatbot as a AI agent, text input, text output. Sensor is the text input, actuator is the text output. What is environment? The environment is everything that agent interacts with, where it operates or performs action. Example, a chessboard is the environment for a chess playing agent. Agent environment interaction perceives what the agent observes, action, what the agent does, performance measure, how well it performs. Types of environments. So the type of environment, the first one is fully observable, meaning agent can see everything relevant to decisions. Example, chess. Next type is partially observable. Agent has limited information. Example, driving a car in fog. Next type is deterministic, meaning next state is predictable. Example, mathematical puzzle. Next type of environment is stochastic, meaning randomness involved. Example, card games. Next type of environment is static, meaning is environment doesn't change while agent thinks. Example, crossed puzzle. Next type of environment is dynamic, meaning environment changes over time. Example, real world navigation. Search in artificial intelligence. Definition: search is a fundamental technique used by AI agents to find a sequence of actions that leads from the initial state to final or goal state. AI problems equals to represented as search problems. AI solutions is equal to search for the best path or action sequence. So the components of search in AI is, the first one is initial state, that is starting of the agent. Goal state, it is the final state. Actions, possible moves the agent can take. Next is path cost. Path cost, it is the numerical cost associated with each path used to find optimal solution. The next one is search tree. So it is a structure used to represent possible states and action. So here you can see the types of search algorithm. It is divided into uninformed or blind algorithm. So informed search algorithm. So under uninformed search algorithms, we have breadth first search, uninformed cost search, depth first search, depth limited search, iterative deepening depth search, bidirectional search. In case of informed search, we have best first search, A star search. So here, what is uninformed search is, it is also called as blind search. No additional information, only problem definition is used. So in case of informed search, it is a heuristic search. The other name for informed search is heuristic search. It uses heuristic, that is extra knowledge or estimate, to guide the search. Uninformed search algorithms. So as we discussed, so we have BFS, DFS, UCS, depth limited search, and IDS, iterative deepening search. So BFS explores all nodes at one level before moving to next. Depth first search algorithm explores as far as possible along each branch before backtracking. So UCS, uniform cost search, expands the node with lowest path cost. So that means GN is lowest path cost. Next, depth limited search. So DFS with a fixed depth limit. DFS with a fixed depth limit. So IDS, iterative deepening search, repeated DFS with increasing depth limit. What is DFS? DFS is depth first search. So in case of IDS, so it repeated DFS with increasing depth limit. What are the key features? In case of BFS, the key feature is find shortest path. That is, if cost is equal to 1 per step. So the key feature of DFS is less memory may get stuck in deep path. So uniform cost search key feature is optimal when cost varies. Depth limited search, it prevents infinite loops. Depth limited search prevents infinite loops. And iterative deepening search combines BFS optimally plus DFS space efficiency. Breadth first search, it's also called as BFS. So it explores nodes level by level. It uses a queue, and it also finds the shortest path if all edge costs are equal. So for example, so the start After that, it finds A. So next it finds B. Next it finds C. So here we can have this example. So the start is this one. Okay, start. So next it moves to 2. So next it moves to 1. After that it moves to 3. And next it moves to 5. So it finds the shortest path if all its costs are equal. So how it works? BFS explores level by level, that is, it visits all the nodes at one depth before going deeper. It uses queue to keep track of nodes. So for example, as I said, when it starts, it comes to the first node. After that, it goes to the second. And before going into the last one, it comes to the parallel one, 3. And next, it goes to 5. So that is the order. 2, 1. So next, it will not go to 5 because it is the last node. It is the deepest one. So next, it goes to the 3. And next, it comes to the 5. That is the last before going into the deeper node. Okay, so this is the breadth first search. So what are the characteristics of this BFS is? So it will find a solution if one exists. Okay, that is the complete. If all step costs are equal, BFS finds the shortest path. Okay, so if all nodes cost are equal, so it will find the shortest path. So next, what is the drawback is it uses lot of memory, right? Because it will go through each and every node, right? So while it's going through each and every node, it uses a lot of memory. That is the drawback of this BFS. Next one is depth first search. In short, it is called DFS. So it explores as far as possible along one branch before backtracking. So it uses a stack or recursion, may go deep into infinite paths and miss shorter solution. Example. So if we start from A, it will go to A1, and from A1 to A2, there is a dead end, and next again backtrack, and it is coming to B. So here you can see how it works. It will start from 2, it will start from 2, it will go to 1, it will come to 5. So that is the dead end, right? So this is the dead end. So again it backtracks and it will come to 4, and after 4 it comes to 5. Okay, so this is how it is going to work. But what is the difference between previous one and this one is it is going that so the previous breadth first search it uses the shortest path. Okay, so it is going to find the shortest path. But here it so this DFS may go deep into the infinite path and miss the shorter solution. So 2 to 1, 1 to 5. This is the last one, and again it backtracks and it goes to 4 and it comes to 5, so that it will cover all the nodes. Okay, so when it is covering all the nodes, it misses the shorter solution. That's how it's going to work. So again, as how it works means DFS explores as deep as possible along one path before backtracking. That is, this is the one path, and after finishing it, it will go to the another path. This one. It uses stack or recursion. Now, what are the characteristics of this DFS is? It may go into infinite loops in infinite search spaces. That is the one. Second thing is it doesn't guarantee shortest path. So why? Because as I said, it explores as deep as possible, right, in one path. So that's why sometimes it will not. There is no guarantee that we are going to get a shortest path. And the advantage is very low memory usage. So next, depth limited search, which is also called as DLS. DFS with a limit one depth, it prevents the infinite loops. But if the limit is too small, it may miss the goal. So example, limit equals to 3, search stops after 3 interval. Iterative deepening search, in short, it is called IDS, runs DLS repeatedly, increasing the depth limit each time. It also combines the space efficiency of DFS and completeness of BFS. Example, it runs the DLS with depth 1 to 2, 2 to 3 until the goal is found. Next one, Uniform Cost Search. In short, it is called UCF. It expands the node with the lowest total cost.
works even when the step cost is very implemented. It's going to implement it where using priority queue equivalent to the Castro algorithm. So, for example, here you can see how it's going to work. So, it is a starting position. Okay. So, 1 to 4. So, you can observe 1 to 4, 1 to 4. The cost is 2 plus 4, that is 6. Okay. So, from 1 to 4, the cost is 2 plus 4, that is 6. But when you start from 3 to 4, the cost is 3 plus 4, that is 7. So UCS, that is Uniform Cost Search, will explore the start from 1 to 4. That is lowest cost step. That is from here to here. That is from here to here because the cost is 2 plus 4 is 6, which is less compared to 3 to 4, that is 7. So how it works is UCS always expands the lowest cumulative cost. It uses a priority queue based on path cost, not depth or order. So as I said, it uses the priority queue based on the path cost, not on depth or not on order. Path cost means, so when it is going from 1 to 4, what is the cost? So here it is 2 and here it is 4. That is when starting from 1, so when it is going to 1, so the cost is 2. Now when it moves from 1 to 4, the cost is 4. The total is 2 plus 4, right? 2 plus 4 is 6. That's how it's going to work. In the opposite way, if it wants to move from start to 3 and 3 to 4, the cost will be 3 plus 4. It is higher. So that's why it is going to prioritize the queue based on the path cost, not on the depth or not on the order. So characteristics, if all steps cost is greater than or equal to epsilon, so finds the least cost step or path. So as I explained here, used in path finding. So like the Castro algorithm. Informed search algorithm, it is also called as heuristic search. So, informed search algorithms, also called as heuristic search, uses extra knowledge called heuristic to guide the search toward the goal more efficiently. So, a heuristic is a rule of thumb or an estimate of how close a node is to the goal. Example, in a map search problem, like finding the shortest route between two cities. So in that case, so as you know, right? So in the Google Map, wherever if you go, so we will be having that so to and fro location, that is the source and destination. So in between that, so what is the shortest path? So it is going to map. So here, this is the algorithm, informed search algorithm. They are going to use to find the shortest route between the two cities. And uninformed search, so BFS or ECS only knows the road connection. Informed search, a greedy uses a straight line distance to destination as a heuristic. So this is very, very important. Please remember this, the term G of n, H of n, and F of n. So what is the meaning of G of n is actual cost. This is the actual cost from the start node to current node. There is a G of n. So please remember, G of n is nothing but actual cost from the start node to the current node. And H of n is heuristic estimate of cost from n goal to n to goals. Okay, so H of n is heuristic estimate and F of n is the estimated total cost, G of n plus H of n. So please remember this. G of n is the actual cost, H of n is the heuristic estimate, and F of n is the total cost, estimated total cost. That is G of n plus H of n. So types of informed search. So here we have pure heuristic search, best first search. It is also called as greedy search, and A star search algorithm. These are the three different algorithms we have under informed search. So what is pure heuristic search? The description is it chooses the node with the lowest heuristic value, that is H of n. Okay, so it is going to choose the node with the lowest heuristic value, that is H of n, and ignores the path cost. It is not going to consider the path cost. The key concept of pure heuristic search is it is fast but may not find optimal solution. Okay, so it is fast but may not find optimal solution. That is the key concept of this pure heuristic search. And when it comes to the greedy search, that is best first search. So it expands the node that appears closest to goal. Okay, it will expand the node that appears closest to the goal using H of n. What is H of n? It is a heuristic value. The key concept behind of or the key concept of this greedy search is it will not guarantee it will not guaranteed optimal. Okay, so greedy approach it is not guaranteed optimal. Next, A star search algorithm, it expands the node with lowest total estimated cost, that is f of n is equal to g of n plus h of n. And the concept is it balances the path cost and heuristic, optimal and complete if h of n is admissible. That is the concept of A star algorithm. So we are going to discuss one by one. The first one is greedy best first search. As I said, it chooses the node that appears very close to the goal based only on h of n. What is h of n? It is the heuristic value. So, and ignores the cost to reach that node. That means it is not going to choose the cost. Okay, so it is not going to choose the path cost. Instead of that, it is going to select or choose the node that appears to the closest to the goal. Okay, so next one, for example, so formula is f of n is equal to h of n because it is not going to consider the g of n. Okay, please remember this. F of n is the total estimated cost. So the total estimated cost is nothing but it is the sum of h of n plus g of n. But here it is going to very greedy search. Okay, so greedy search it is going to choose only the closest node to the goal, but not the path of cost. Okay, please remember that. That's why so they are not going to consider this g of n. So here it is f of n is equal to h of n. So example is so choose B the smallest one. Choose B the smallest one. So out of all these three, so for example, h of A is 5, h of B is 2, and h of C is 7. So okay, so out of all these three, this is the smallest one. As I said, it is not going to choose the path cost. As I said, 5 plus 2 is equal to 7, right? So it is not going to select this 7. So it is going to select only the closest to the goal. Okay, so that is choose B smallest edge. Next, what are the pros? It's fast and memory efficient. That is the advantage. When it comes to the disadvantage, it will not guaranteed. So not guaranteed to find the best path because it is going to find only the closest goal, right? So it will not. It will ignore the path cost to reach that node. So not guaranteed to find the best path and can get stuck in loops. Okay, if it is infinite loop, it keeps on infinite. Okay, so it can get stuck in loops. That is the disadvantage. And next come to the A search algorithm or A star algorithm, A star search algorithm. So it uses both actual cost and estimated cost. It is going to use G of n and H of n. So, but previous one, greedy search. Okay, so please remember the greedy search is not going to use the G of n. Okay, so both actually, so here it is going to use both actual cost and estimated cost. So it's going to select the node with the lowest total estimated cost. For example, so as you know that f of n is equal to g of n plus h of n. So in previous greedy search, so this was not there. So here in the A star, okay, so in the A star search algorithm, so we have f of n is equal to g of n plus h of n. So what are the disadvantages or advantage? Okay, so that we are going to study one by one. So the first one is advantage, pros. So it is complete. Okay, so yes, it is complete if ranking factor is finite. And whether it is optimal, yes, it is optimal if heuristic is admissible. Okay, never overestimate. And whether it is efficient, yes. So expands fewer nodes than UCS or BFS. It is efficient. Complete, optimal, efficient. These are the three advantage. And example is if you are driving from Bangalore to Mysore, okay, so if you are driving from Bangalore to Mysore, G of n is the distance already traveled. So Gn is the distance I've already traveled, and h of n is the straight line distance left. Okay, so straight line distance left, and A star picks the route minimizing. So the distance so far plus distance remaining distance so far plus distance remaining. So that is the that's the one which A star is going to pick. Next, comparison between uninformed and informed search. So the first column is future, second column is uninformed search, and the third one is informed search. So the first difference is uses heuristic. No, uninformed search it will not use the heuristic, and informed search yes it is going to use. Second advantage, second feature is knowledge use. So in case of uninformed search, the problem definition is only they're going to use. And in case of informed search, so the knowledge use, yes, so for problem definition and extra information. So example for uninformed search is BFS, DFS, UCS, and informed search is so this A star, 3D, and IDA. So when it comes to the speed, so uninformed search is slow because of blind. So it's also called as blind search algorithm. And informed search is fast because it is guided. And next feature is optimal. So uninformed search is optimal? No, sometimes, okay, not always. Informed search is often because A star guarantees if heuristic is good. Okay, so these are the comparison between uninformed and informed search algorithms. So thank you. So this knowledge representation we are going to discuss in the next video.